Hello friends. Let us solve some of the questions, the remaining questions of portfolio management that is forming the fifth part, that is others. We are solving first question C 4.5.1 from classwork. Now try to understand. Before solving this, let me clarify. We have already learned Markowitz frontier. That should be a basic knowledge for solving this particular question. Also, we have understood what is minimum risk portfolio. Is it alright? Minimum risk portfolio, if you have forgotten, let me just revise the formula by which we have found out. If there are two securities and we want a minimum risk portfolio, the portfolio combination which will be giving maximum return, no, which will be giving minimum risk, then I need to find out that is weight of X will be is equal to standard deviation of y whole square minus covariance between x and y divided by standard deviation of x whole square plus variance of y whole square, variance of y, that is standard deviation of y whole square minus 2 covariance between x and y. You remember we have not elaborated this formula, but this is weight of x, which will be the answer. Say weight of x is 0.40, then weight of y will be 0.60. This will be your weight for x and y in your portfolio, so that the portfolio created in such a manner will be best, no, will be having minimum variance or will be having minimum standard deviation. With any other combination, you may increase your return, but you are not able to reduce your risk as compared to this particular portfolio having this particular weights. Right. So this is minimum risk portfolio. Let me also explain you in the form of Markowitz model. We have already understood Markowitz frontier. We have also understood that capital market line. Which should be tangent to this. This portfolio will be having highest Sharpe ratio. That also we have understood. Is it alright? But try to concentrate. There are other portfolios. Let me change the color. Is it alright? This is standard deviation. This is return. Is it alright? So there are other portfolios which is having less standard deviation, like this particular portfolio. Among all the combinations of weight of different portfolios, this is one of the best. Is it right? No, not one of the best. Is it one of the best? No, not one of the best, but this is a portfolio having minimum variance. It is having minimum standard deviation. If it is having minimum standard deviation, sir, this is not having minimum. There is no portfolio. The portfolio lies over here on this Markowitz frontier. So this portfolio is minimum variance of portfolio. Now try to understand in this particular question. An investor has two portfolios known to be on minimum variance. So try to, I'm rubbing this line. Now, the line passes through this particular figure. Say it is this line. Is it alright? And this is minimum variance set. There might be one portfolio, there might be two portfolio, there might be 10 portfolios on this particular point. Is it alright? With different combinations of different securities. Is it alright? So, let me start with the question. An investor has two portfolios known to be on minimum variance set. So there are two portfolios which are already on minimum variance set for a population of three securities A, B and C. So there are three securities A, B and C. Below mentioned weights. So these are weights of portfolio X, portfolio Y. It is supposed that there are no restriction on short sales. What would be the weight of each stock for a portfolio constructed by investing rupees 5,000 in portfolio X and rupees 3,000 in portfolio Y? 5,000 rupees in portfolio X and 3,000 rupees in portfolio Y. Three securities A, B, C. What is the weight of A in portfolio X? 0.30. It will be 1,500 rupees. 0.40, 2,000 rupees. 0.30, 1,500 rupees. Total will be 5,000. Yes. A is having how much weight in portfolio Y? 0.20, 600. 0.5, 1,500. 0.3, 900, and the total will be 3,000. Start. But if you have invested this proportion in different portfolio, what would be total amount invested in A, B, and C individually? In A, you have invested 2,100. In B, you have invested 3,500. In C, you have invested 2,400. And total will be is equal to total of this, which is nothing but 8,000. Start. They are asking us weight of each security in our this portfolio. Start. I will be just finding out weight by 2,100 divided by 8,000. It is 0.2625. No. You need to find out weight. So this should be taken as 100. Let me take it as 1. Yes, then it is correct. 2,100 divided by 8,000, it is 0.2625. 3,500 divided by 8,000 is 0.4375. And 2,400 divided by 8,000. It is 0.3. And the answer should be 1. Start it. The total weight should be 1. Let me verify whether it is 1 or 2625 plus 0.4375 plus, yes, 0.3. The total answer will be 1. Start. So, these are the weights of security A, B, and C respectively. If the portfolio is constructed by investing 5,000 in portfolio X and 3,000 in portfolio Y. Now, next question is somewhat typical. Try to concentrate. Suppose the investor invests rupees 4,000 out of 8,000 in security A. So 4,000 you have invested in A. Remaining you will be investing in B and C. And total amount available is 8,000. That's right. How he will allocate the balance between the security B and C to ensure this portfolio is still on minimum variance set? If you want minimum variance set, your portfolio should lie over here. For finding out that particular point, I will be finding out slope and origin of this line. Origin and slope of this line. For finding out, yes, suppose this portfolio is minimum variance set, yes. Then the line which passes through this portfolio, which passes through this portfolio, will pass through our portfolio also. Sorry. So, I am just finding out, and how to find out, try to concentrate. I am just taking two securities right now. Start it. Weight of B. Let me draft a line. Weight of B is equal to origin. Let me denote origin as A, whereby we normally denote it as A. Plus B is my scale, will be is equal to weight of A. What will be weight of B? What is weight of B in first line, portfolio X? Weight of B is 0.40. Origin I want to find out, B I want to find out, and weight of A is 0.3. Similarly, second portfolio, that is portfolio Y, is also on same variance set. Is it alright? From portfolio Y, can I take this equation 0.5 is equal to origin plus scale into 0.2. Start it. By solving this two equation, I'm not solving it actually, but if you solve this two equation, there are two equations, two variables. By simultaneous equation method or any other method, you can easily solve it. If you find out your origin and scale, I'm writing origin and scale directly, you need to find it out. Origin will be 0.70 and scale will be -1. Start. So this new portfolio, say portfolio new, will be also passing through a line having same origin and scale. The answer is yes, because it is on minimum variance set. So new portfolio weight of B should be 0.70 plus -1 weight of weight of A is already there. It is 0.50. See over here, what is weight of A is 0.50. This is 1. Sorry. So weight of A already is there. So I will be getting answer of weight of B. Weight of B will be is equal to 0.70. This will become minus, and weight of A is 0.50. So weight of B will be 0.20, that is 20%. So weight of B will be 0.20. 0.20, that is 20% of 8,000 is 1,600. So the amount invested will be 1,600. I need not find out weight of C by this all formulas, because the balancing figure will be weight of C. Weight of C will be 0.30 and it will be 2,400. Believe me, this portfolio will also be a minimum variance portfolio. Sir, then portfolio X and Y will also be a minimum variance portfolio, and this portfolio will also be a minimum variance portfolio. This is the method to find out minimum variance portfolio.